It's been a while since I've published a video, which is due to spending more time on the projects that I'm working on. I'd like to introduce one of the projects in this video, but the video is more about some of the challenges I've faced and the pros and cons of two different programming languages, specifically about Python and C. I'm going to be giving my personal opinions in this video, but I don't want to give the impression that I love Python and I hate C. That's only partly true. I do generally prefer programming in Python. Just look at the number of my past videos that I use Python. But I've also got a lot of respect for C as a programming language. C is the first programming language I properly learnt to program in, except for a little bit of BASIC and some machine code. Yeah, I do mean machine code rather than assembly language, but that's a different story. C is certainly a very powerful language. During this project, I did create a version that used a combination of both languages, showing that there is scope for working side by side. I initially tried to do this all in Python, and then I decided the advantage of using C meant it was worth adding that to the mix, although I'm now looking at implementing in just Python, but using a slightly different architecture and approach to how I'm programming it. Before we get into the details, here's a quick introduction to the project so far. This is part of a project to allow a Raspberry Pi to control a model railway. This is also relevant if looking at interfacing with other electronic projects where there is a USB interface, or direct UART or similar serial connection. This uses CBUS, which is based on CAN bus, which is a protocol used in electronics of modern cars and other transport methods. Using CBUS allows DCC model railway control over the same electrical bus as accessories such as point controllers, on-track detection and lighting, etc. I won't go into details here as I've already made a video about CBUS. See the link in the description. Instead, I'd just like to concentrate on the interface that I use with the Raspberry Pi. In this case, it's the CAN USB 4 module from the Merg kit locker. The CAN USB 4 connects to a Raspberry Pi or other computer using a USB interface, which acts as a serial connection. So in theory, it's just a case of reading and writing to a serial port. Which brings me onto the application, or what I've created so far. The main thing I'm wanting to create is a GUI application, which allows control of trains and accessories. I also want the ability to automate certain actions, perhaps creating a sequence of events. And I also want to be able to provide some kind of web-based API, which could provide a means to provide a wireless control, perhaps using a mobile phone or other device. My first thought was to do this just in Python. That is typically my first choice of programming language, as it's very easy to program. It's a nice language in terms of structure, and it's also easy to program using object-oriented programming. It's also really quick to program with lots of modules available, and it's very easy to code in. It's also good for portability, though that's not so important in this, as this is specifically designed to run on a Raspberry Pi. One negative part of Python is that it is an interpreted language, which comes with a performance hit. I didn't think that would be a problem with the amount of traffic generated, but compared to some other things I did, it turned out to be more than an issue than I expected. I've recently been creating some GUI applications in Python and Pyside, which is based around the Qt framework, so that was a natural choice for the GUI application. I've already created some related videos. In particular, you may want to watch the video on QThreadPool, which explains about some of the challenges for using threading in Python. In that video, I pointed out that whilst threading is an easy way to create more responsive application, one of the pitfalls of using threading is that still run on a single processor core and constrained by the global interpreter lock, which is a Python feature. I still tried to create this within the GUI application, but because of the limitation of the threads, I therefore tried true multiprocessing instead. Created multiple processors to handle the GUI, serial communications, automation and server, and then used multiprocessing queues to communicate between the different processors. The problem was the overhead of creating lots of different processors, and the different message queues resulted in poor performance. One method I did get to work was to create this as two separate programs that were able to exchange messages. I used zero message queue for the communication between the server application and the GUI. I did get that version working and was able to see the messages coming across the bus, as well as be able to send messages to control accessories such as switching the points. However, the performance was still quite slow. When adding the control of a DCC locomotive, I realised the performance was going to be a problem. As well as sending messages to control the loco, it would need regular keep alive messages, as otherwise the DCC controller assumes the handset, or the Raspberry Pi in this case, has disconnected. I could improve the response by checking the serial port more frequently, but that also increased the demands on the processor. This is where I decided to try using C. The serial libraries built into C allowed communicating with serial devices using non-canonical mode, which allows you to quickly check to see if there's any data. I then used LibMicroHttpd as a web API which the GUI application can communicate with. I still needed these running at the same time, but without the global interpreter lock, I could do this in threads rather than using separate processors, reducing the impact on performance. I then implemented a single POSIX message queue for one direction to allow the API thread to pass requests for the main thread and then to pass to CBUS. This has some overhead, but means I don't need to implement my own mutexes or spin locks, etc. The data going the other way from the main thread with the incoming serial data to the API, then that can be handled using shared memory. This is much faster than having to use message queues, and because the API only needs to read the data in the memory, then that can be done much faster. As this is where a lot of the data needs to be transferred, that was much better. Also factoring that C provides compiled code that runs really quickly, I was able to significantly improve the performance. Using this, I was able to at least prove that this could work. This was not all good news though, as I found it much harder to write the code in C. One thing is that because most of my recent code is in Python, my C programming was a little rusty, although it's surprising how quickly that comes back. Another, lack of direct support in C for some functionality that I now take for granted because of using Python. String handling is a good example, as that is one thing that Python does really well and in a much more intuitive way than using it in C. But one of the main things is having to be responsible for managing memory. Whilst it made it a little easier using large arrays, rather than needing to use malloc to allocate blocks of memory, I had to create a cyclic data store and had to ensure the tracking of the use of that memory. And then when programming in C, the code needs to be compiled first. This turns the code into a form that can run directly on the computer, compared to the Python code which has to be converted through the interpreter at runtime. This means that the code does run much faster. However, as I've said, the negative side is that you're responsible for allocating the memory, and it's easy to read or write to invalid memory. A stray pointer can easily create a segmentation fault, or even stack smashing. That's a new one on me, as I'd not seen that error before. But basically a similar problem, but as local variables are typically stored on the stack, a stray pointer can overrun outside the normal allocated area. My initial segmentation fault was due to an off by 1 error, which is a very easy mistake to make. And the stack smashing was due to not allocating enough memory space for the amount of data that the server had to return for the message. Whilst I fixed both of those, I still get an occasional segmentation fault, which is likely due to insufficient memory being allocated. When these errors occur, then it can be a challenge to debug. Unlike with C, which normally shows exactly what happened, with C you just get a segmentation fault or similar error message as the one shown here. There are debugging tools, but it's sometimes much harder to find and fix the bugs in C code than this would be in an interpreted language such as Python. Again, there are some other advantages to C. It's statically typed, so the data stored in a variable can be checked during the compiler stage, and that can help problems which can be harder to find in dynamically typed languages such as Python, a problem I've certainly experienced in the past. So whilst the C server proved that it could be done in C, I really wanted to create a fully Python-based solution. There are pros and cons to using C and Python, but if possible, I wanted to avoid having both. The reason being that whilst it's easy enough to install the Python libraries or to compile a C program, I wouldn't really want someone to have to do both just to install a single application. I'd already decided on Python for the GUI, so ideally I wanted to do the same for the server part of the code. In the end, I decided to try using Flask. This is a web framework for Python, makes it easy to create a web API. Effectively, the Flask framework includes its own web server, although they do recommend using an external web server for any situation where a lot of connections are required. I have used Flask a number of times in my other projects, and I've used some of the source code from my Pixel server code to get this up and running quicker. The main thing I did to get it working this time, compared to the previous attempts with the Python server, is to keep the code simple. So it's not trying to spin up multiple processors or to perform any of the device discovery or automation. It does use threading, but I've also streamlined the code required for checking any serial data to improve the performance. It's early days yet, but I think that I'm going to be using that in place of the previous C code that I wrote. So far, I've got the basic server working, and the GUI is able to communicate through the server and onto the CBUS. I can now take control of a loco, change the direction and speed as appropriate, and the GUI is responsive. The load on the process is a little bit higher than when the C server was in use, but it's much better than the previous examples where the overheads were too high. I'm running this on a Raspberry Pi 4 and it's responsive enough. This screen shows two parts to the GUI. The window at the back is the main window, which provides a way to control accessories and a loco, and in front is a console window, which can be used to monitor all the traffic on the CBUS. In the main GUI window, there are buttons that control the direction or can stop the loco, a dial that allows control of the speed, and then a selection box at the bottom that allows me to select different functions, particularly sounds. I can also switch tabs and control the points on the layout, although eventually that will be selectable through a layout image on the right, which I haven't developed yet. So this is what I plan to do in the future. Firstly, to expand the API, which is most likely to be the Python version. I'll add some source code for authentication, etc. I also plan to add some missing features for the loco. I've only added the direction and speed control so far. I need to add support for the function buttons for sound and a few other features. And a means for automation. The idea is to have some commands that can be issued that instruct it to say, run until detected by a certain sensor. For example, the option to send a loco running and have it automatically stop when it reaches a station. I also plan to add a layout image with the option to click on the points or switches to be able to control that point. I also need to write up more details, and I'll be adding more videos explaining this in the future. If you'd like to see updates in the future, please click subscribe and click on the notification icon so you'll get notified whenever a new video comes out. Thanks for watching. This has been a bit different to my other videos, but I hope you've found something useful in it. I'll be providing more project updates in the near future.